Hello, my name is Mrs. Garcia and I'm helping to make these geometry videos for you guys. I'm in room 214 if you have any questions. Previously, in this chapter, you guys were working on proving two triangles congruent, and there was two ways that we could do it. One was through side, 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 SSS, side, side, side. And the second one was side, angle, side. And today we're introducing two more. So the first one being angle, side, angle. So we're going to begin with the proof, not the proof, the theorem here. If two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the two triangles are congruent. So here we can see the picture here. So the deal is it has to be two angles where that side is in between. That's why we call it side, angle, side. It has to go, oops, I'm sorry. I meant angle, side, angle. Angle, side, angle. It has to go in that order. Angle, side, and then angle. Just like ASA, angle, side, angle. So from these that diagram here, if angle A is congruent to angle D and side AB is congruent to side DE, shh, kitty, my cat's meowing, I'm sorry. Angle B is congruent to angle E. So we have an angle, a side, and an angle. Then the triangles are congruent. Triangle ABC is congruent to triangle DEF. Okay, we've got several proofs to do here, 3 of them, and then we'll move on to angle, angle, side after that. Okay, our first one here. And there, just to go back to that theorem, included means that the side is between the two angles, as I was explaining. Okay, we are given that SQ bisects angle RQT and angle RST. And we're supposed to prove that triangle QRS is congruent to triangle QTS. So we have a top triangle and a bottom triangle we're trying to prove are congruent. Now, SQ being the bisector, so it's telling us it's bisecting this large angle, RQT, and RST, that large angle. And so we, as geometry students, need to know that when it says a segment is bisecting an angle, that automatically, the thing that we're supposed to know is that means that it's cutting the angle into two equal pieces. So this is the bisector. That means that angle equals that angle because it's bisecting that larger angle. And on the same thing on the other side, this angle is equal to that angle. So in this proof, we've got the statements written out for us already. That makes it a little bit easier. SQ bisects the two angles. That is given. Next it says RQS. Let me erase my markings over here on the diagram. RQS is congruent to TQS. RQS is congruent to TQS. So these two angles are congruent. The reason why we know that is because it told us this was a bisector, an angle bisector. And so the reason then is that is the definition of an angle bisector. Okay, So we are trying to, we have to keep in mind that our theorem of what we can use, angle, side, angle. So far in this proof, we've proven one angle. Next it says RSQ is congruent to TSQ. And that is the same reason, because this was the bisector, QS was the bisector. We already talked about that angle, and now we're doing this one. So it's the same reason. It is the definition of an angle bisector. All right, so now we have angle, angle, and now we need the side in between the two angles. If you look at just one triangle, we've got an angle, and now we need that side in between. And if you'll notice, QS, it is a side of the top triangle, and it's a side of the bottom triangle. Whenever you have two triangles sharing a side, in your proof you have to say that that side equals itself. It seems a little weird, but that's just what we have to do for our proofs. We have to literally say something equals itself. QS equals QS is congruent. And the reason for that always is the reflexive property. And what that does is that's saying QS belongs to the top triangle, and it's congruent to the side that belongs to the bottom triangle as well. And so now what we have is we have angle, a side, and an angle, and the side is in between those two. Since we have angle, side, angle, we can now say what we were trying to prove. Your last statement in a proof is always the thing you're trying to prove. We can now say that. So QRS is congruent to QTS, and the reason is angle, side, angle. You don't have to write it out. You can just write the letters, angle, side, angle. All right, here is another one, and I'm noticing, I haven't even read it yet, but I'm noticing there's two triangles in the picture, and they're sharing a side as well, so I bet you we're going to have to use that. Let's see what it says. JK is parallel to LM, so I'm going to mark that on my diagram. JK and LM are parallel. Also, JL is parallel to KM, so I'm going to put two little arrows. This is, my screen is a little small, it's hard to write on here. There we go. Okay, so just like above, how you have to keep it in your mind as part of what you just know, that when they say a segment is bisecting an angle, that automatically means the next thing that you say is those two angles are equal to each other. They're congruent. When they give us parallel lines, what you're going to want to do is look for either corresponding angles or alternate interior angles. I'm going to recall, if you have parallel lines and a transversal, here's an example of corresponding angles. Corresponding angles are congruent. We also have alternate interior angles, and those are congruent as well. We learned that in chapter 2. So when I look at this picture, I'm just going to focus for a minute on those parallel lines, and with that being the transversal. In this picture with just the blue lines, I have a pair of alternate interior angles. So I'm going to be able to say that those are equal to each other. They're congruent. And I don't know which angles here that they've given us down here yet. Let's see. It says JKL and MLK. JKL, so this guy, with MLK, with that guy. So that's what I was highlighting. So we have here two parallel lines with a transversal. Oh wait, I think I messed up. JKL with MLK. So that would be, yeah, that would be those parallel lines with the shared side being the transversal. Okay, so they start off with, we list what is given, and we write in the reason it is given. And next up, JKL is congruent to MLK. That's what I've marked already. JKL is congruent to MLK, and that is because alternate interior, and I'm going to abbreviate here, alternate interior angles are congruent. All right, so we have, remember what we have, we're trying to prove two triangles are congruent with ASA, angle side angle. So far, we have an angle. Let's see what we have next. JLK is congruent to MKL. So that was the first parallel lines I had drawn. So because those two are parallel, this guy is our transversal. Now we can mark those red angles, this guy and that guy, as being congruent. And those, again, that's an example of alternate interior angles. Alternate interior angles are congruent. So now we have an angle and another angle. We just need the side that is in between the two angles. And again, just like the picture above, that side, this segment here, is being shared. It's the side of the top angle, and it's the side of the bottom angle. So that is serving as our side in between the two angles. So we've got to say KL is congruent to LK. Reflexive property is the reason. Reflexive property. And so now we have it. We have angle, side, angle in each of our triangles. So now we can say what we were supposed to prove. JKL is congruent to MLK by angle, side, angle. All right, and we have one more before we move on to the next theorem. I just need to grab my water. Sorry, I should have had water with me, but I didn't. Okay, so now we are trying one on our own. The statements are not given to us. Okay, let's take a look at what we have. It says BAC is congruent to DEC. So I'm going to mark that on the diagram. BAC is congruent to DEC. And I haven't even read through them yet, but I'm going to go ahead and start the proof. BAC is congruent to angle DEC. That is given to us. And so looking here, our two triangles, we just have one pair of angles that are congruent. There's another given though, so let's mark that and talk about that one. C is the midpoint of AE. Okay, so it's telling us that C is the midpoint of AE. Just like on the other two proofs, if they tell you an angle is getting bisected, the very next thing that you can conclude from that is the two angles are equal. If they give you parallel lines and a transversal, then you can find alternate interior angles are equal. The midpoint is another one of those. When they say a point is the midpoint, what that means is that those two segments are equal to each other. They're something being a midpoint. Midpoint means the exact middle. So the two halves are going to be exactly equal to each other. So that becomes the next thing I would want to say, is that CA is congruent to CE. First, I got to say that that was given. All right, so now our next statement is going to be that CA is congruent to CE. CA, CE. And that is by the definition of midpoint. And I always abbreviate there. That's okay. Definition of midpoint. So now what we have is we have angles, a pair of angles, and we have the sides. Angle, side, angle, side. We need angle, side, angle. So we need another angle. Looking at our diagram here, another little tidbit that you need to know and remember from previous is that when you have two lines crossing, that creates vertical angles. So these two angles are congruent and these two angles are congruent. They're called vertical angles. And that's what I see in this picture here. We have this guy and that guy, those two segments, and that's created vertical angles. So we can say that angle is congruent to that angle. And then look at one triangle now. We have angle, side, angle in each of our triangles because of adding in those red angles there. So let's name them and write that as our statement. The triangle on the left, angle BCA, is congruent. BCA is congruent. I'm going to keep my letters in proper order. DCE. Angle DCE. And the reason is because they are vertical angles, and that's one of our reasons that we can use. Vertical angles are congruent. All right, we have it now. We have angle, side, angle. Angle, side, angle in each of our triangles. So now we can say that the triangles are congruent. Triangle ABC is congruent to triangle EDC by angle, side, angle, ASA. All right. Excuse me. Another theorem is angle, angle, side. If two angles and a non-included side of a triangle are congruent to two angles and a non-included side of another triangle, then the two triangles are congruent. Again, the order matters, so it goes in a row. Angle, angle, side. That's why they call it AAS. Excuse me, angle, angle, side. So from this diagram here, if angle A is congruent, this pen is being wonky. If angle A is congruent to angle D and angle B is congruent to angle E, so there's angle, angle, and BC is congruent to EF, Then the triangles are congruent. ABC is congruent to triangle DEF. Angle, angle, side. All right, our first proof. It says we're supposed to prove that WYZ, triangle on the left, is congruent to XYZ, triangle on the right. First thing it says is that YZ bisects, YZ bisects angle WYX. So let's look at that on the diagram. WYX is this large angle here. YZ is bisecting that. Remember that from the previous page? If a segment is an angle bisector, that means the two angles are being cut. That one big angle is being cut into two equal pieces. So this was our first given statement. So I write given is my reason. And now directly because of that, I can say those two angles are congruent. So let's name them. Angle WYZ, that's this one on the left, is congruent to angle XYZ, the one on the right. And the reason, definition of angle bisector. All right, we've got an angle. Yay us. Let's see what else it says. YWZ is congruent to YXZ. All right. So that gives us another angle. Angle YWZ is congruent to angle YXZ. And that is given. So we have two angles so far. Are you recognizing where we're going to get our side from? We've got that shared side again. So we're going to say that YZ is congruent to itself. YZ is congruent to YZ. And do you remember the reason? Reflexive. The reflexive property. And so now we've got it. We've got angle, angle, side on each of our triangles. And I forgot to circle them as we were going along. We have angle, angle, and side. We just proved it. Now we can write our statement that we're supposed to prove is always the last statement in your proof. Triangle WYZ is congruent to triangle XYZ by angle, angle, side. AAS. All right. Are there any more? Oh my goodness, there's 3. I think that we should pause and you guys try this one on your own. So the teacher listening, if you could please push pause and give everybody about 5 or 6 or so minutes to try and do this one on their own. And then hit replay and I will go over it. All right, we have triangle, angle ABC is congruent to triangle CED. All right, let's make that be our first statement here. Congruent to angle CED, and that is given. And okay, I marked it in our diagram. I'm not able to say anything else from that, so let's move on to our next given. AB is parallel to CE. AB is parallel to CE. Okay, let's mark that with our little arrows there. Okay, remember what I said about parallel lines? You have parallel lines with a transversal. You're going to find alternate interiors, or corresponding is another one that you'll use a lot. It's usually either of those two, alternate interior or corresponding, for these types of proofs. So I'm going to highlight my parallel lines. Okay, I've got two options for my transversal. Are we talking about this one, or are we talking about this one? Let's explore that first one. If it was this one, my alternate interior angles would be this guy and that guy. Well, that angle isn't even a part of the triangle, so that isn't making any sense. Or that angle ain't. And that angle, which again aren't a part of the triangles. So what if this is the transversal they're talking about? Two parallel lines with the transversal. Aha! That gives us those two corresponding angles. So we can say, because of corresponding angles, those guys are congruent. So let's name them. Angle BAC is congruent to angle ECD. And that is corresponding angles are congruent. Corresponding angles are congruent. And the one above, I forgot to write given, so let me just do that really quick. All right, so we have angle and angle. We have two angles so far. We have another given though, so we're going to be able to pull some more. Let's do that one next. C is the midpoint of AD. C is the midpoint of AD. That is given. Now let's look at the diagram. C is the midpoint of AD. We did a midpoint on the previous page. When they tell you something's a midpoint, you can say those two halves are equal. So that's going to be our next statement. AC is congruent to DC. Definition of midpoint. That is the very definition of midpoint. Something's a midpoint, therefore the two halves are equal. All right, we have now angle, angle, side. Angle, angle, side. We can now say the two triangles are congruent. Triangle ABC is congruent to triangle CED by AAS. Angle, angle, side. Now, if there's time in class, teacher, please pause and have everybody try number 6 as well. The more you try these on your own, the better off you're going to be. You've got to give it a shot and keep trying, and also do your homework. All right, we have, I like to start just by writing that first thing, and then I'll look on and see what we have here. So PR bisects angle QRS. Okay, QRS is this large angle. PR is the bisector, so let's write that it's given. And so hopefully you guys have clued into what we would say next now. When they give you an angle bisector, you say that the two angles are congruent. So I've got to name those. So that would be angle QRP is congruent to angle SRP. And the reason is the definition of angle bisector. All right, we have one angle so far. I'm noticing we do have another given, so let's do that one next. Angle PSR is congruent to angle PQR. PSR is congruent to PQR. So I've marked it there, and so that is another angle for us. And the reason on that one is it is given. All right, look at our diagram. Are you noticing anything else that we can do? We have two angles so far. Remember, the two triangles are sharing a side, so that can be our side for our proof. And whenever two triangles are sharing the side, you got to say that that side equals itself. PR is congruent to PR. And that is the reflexive property. We have angle, angle, side. We did it. Let's write it out. Angle PSR is congruent to triangle PQR by angle, angle, side. And once again, teacher, please push pause and give everybody a chance to try number 7. And hopefully there was enough time in class for that. All right, let's go. LG is parallel to JM. Okay, so just because they said parallel, I've got it in my brain now. So I'm going to be looking for either alternate interiors or corresponding. Let's write that it's given. And let's come over to our diagram and mark those. LG is parallel to JM. Let's just, without moving on to the next given, let's find what angles we're able to say from that. So we have, those are parallel, and I've got two transversals, so I'm just gonna, I don't know that it would matter, I'm gonna pick this guy to be the transversal, and so angle and angle, those would be alternate interiors. So I'm going to say that angle equals that angle because alternate interior angles are congruent. So that would be, and since there's only one angle coming off of vertex G, I don't have to use the 3 letters to name that angle. I can just call it angle G. Angle G is congruent to angle J by the reason alternate interior angles are congruent. All right, we've got one angle. I'm going to move on to the next given. H is the midpoint of LM. Given. And let's look at our diagram. H is the midpoint of LM. Do you remember what you're supposed to say next? Yep. HL is congruent to HM. Directly, because they said midpoint, the very next thing we say is the two halves are equal. HL is congruent to HM. And the reason? Definition of midpoint. Okay, so far we have angle and a side. Angle and a side. We're out of givens. We don't have any more given statements. So let's look at the diagram. Do you notice anything? Is there anything else we can say about these triangles? Hopefully you've noticed we have two crossing segments, and that creates vertical angles. Vertical angles. So let's name those. and say that they're congruent. The one on the left, angle LHG is congruent to angle MHJ. And that reason is that vertical angles are congruent. All right, we have it. We have angle, side, and now another angle. So we can say our proof now. And triangle LGH is congruent to triangle MJH by angle, angle, side. There we go. That is it for 4.4. Please, please, please do your homework. And come and see me if you have any questions.